Hi, Peter here. This video is a follow-on from the first video on debugging. Here we apply the same techniques to another problem. The function we are looking at tests to see if a given list is sorted. We do this by comparing each pair of adjacent elements. If any pair is out of order, then we return false. If not, we return true. Okay, let's see what happens. So here's our function definition, and we've got a few examples. We've loaded it up. So let's try and see what happens. Okay. So let's try sorted. We may as well try the first example, 1, 6, 2. So that's a list that's not in order. Oh dear, what's going on here? Okay, we've got some kind of error message. So let's look at the error message and try to understand what it's saying. And the best place to start is at the very last line. So this says it's a type error. So something's gone wrong. We've given one kind of thing to range and it was expecting another kind of thing. So range says integer end argument expected got list. So what does that actually mean? Well, let's try help of range. And we'll see that range, if we look at it, it's basically expecting, for example, range of 4. So we're expecting it to give an integer, and it's complaining because although it wants an integer, it's got a list. And if we look at the second last line of that error message, it gives you where it thinks the problem is, and you'll see that it's got range in that line. So let's look at that in the program. So we've got range of XS. Oh, I see. XS is a list and we're expecting an integer. What we really meant to do is write length of XS. Silly of me, but an easy mistake to make. So let's save that and load that. And let's try is sorted again. Oops. We've got rid of the type error, but this is not a sorted list, and we've got true. So what's going on here? Well, let's use the same technique as we did in the last example, and that was we've got a loop, so let's put a print statement in. So what's interesting to print here? Well, the index we're working on is interesting to print, but since we're doing a comparison between two adjacent elements, it might be a good idea to print those two adjacent elements, because clearly we've got a mistake somewhere. So something has gone wrong. So let's print all three. So we've got the index, so we know how far through the loop we are. We've got the value of XS at I, and we've got the value of XS at I plus 1. And then we can see if this test should succeed or not based on the two values we've just printed. Okay, so let's save that and load that and run our test again. Okay. Well, what's going on here? Well, it's only gone through the list once. Well, it's only gone through the loop once. And okay, so what's happening here? So 1 and 6, so XS of 0 is 1, and this is 6, and 1 is not greater than 6, so they're in order so far. So we don't return false. And what's happening is, we got the same problems we had last time. We're returning true inside the loop, and we didn't mean to do that. So let's move it outside the loop. So now it's where we want it to be, outside the loop. So let's try that again and see what happens. So we load that again, and we try our list, 162. Okay, now what's happened? Well, it was printing 0, 1 and 6, so that's the first time through the loop when 1 is less than 6, so the if test fails correctly, and then we come back and now I is 1 and the numbers to compare are now 6 and 2. Now 6 is greater than 2, so the if test should indeed return false, and therefore we should exit our function returning false. So this is behaving correctly. Good, excellent. So far so good. Okay, let's try our next test. So we've got 6, and then it was 1 and 2. So let's try that one. Okay, so what's going on here? Well, we got 6 as the first element and 1 as the second element. 6 is greater than 1. So indeed, that's out of order and it should return false, and it does. Okay, good, excellent. We're making progress. Okay, so let's try the next one, which is 1, 2, 6, which is the one that's in order. So hopefully this will return true. Oh dear, we weren't expecting that. Out of range. Okay, what's going on here? Well, let's look at the printout. We get 0, 1 and 2. So the first time through the loop, it compares 1 and 2 and says, yep, they're in order, no problem. So then it tries the second one, second pair. So this is 2 and 6. So that's 2 and 6, and 2 and 6 are in order. Yep, no problems. Then it goes to the third list, the third element, and it's 2 and 6, and oh, it's not printed anything here. So something has gone wrong here at this point. And if we look at it, the error message, so again, look at the last line, index error, list index out of range. And it's at this print statement. And we printed the I, we printed the excess I, but we didn't print this one. Okay, so the culprit looks like excess I plus 1. And indeed, if you look at the case we've got a list of length 3, and we've got our indexes being 2. So this will be excess of 2 plus 1, which is 3. But the list is only of length 3, so we don't have an index at position 3. So this is what's going on here. The list index is out of range. Okay, let's go and look at our program and go, okay, well, the problem is we've just gone too far with I. Not because of the excess I, but because of the excess I plus 1. And so we can see by our example in the code that actually comparing 2 and 6 is the last thing we wanted to do. So the problem is we've gone too far. So we don't want to go to the length of excess. We want to go to the length range of excess minus 1. So that seems to be to fix that problem. Let's try and see. Save that and load it and try that. So is sorted to 1, 2, 6. Okay, good. Now it goes 1 and 2 in order, correct. 2 and 6 in order, correct. No problem. Okay, so far so good. What we should do at this point is not be too confident. We should go back. Now that we fixed this problem, we might have introduced a bug in fixing that problem. So what we really should do is go back and look at all our examples. So we try 162. That's still giving us a problem. Oh, it's still succeeding. Well, it's correctly giving us the right answer. And 612, that's also giving us the correct answer. And just to confirm again, 126 is okay, so that gives us true as we expected. And let's try our last two examples. The empty list can often cause a problem, so it's usually a good idea when you're doing list processing to especially check the empty list. In this case, the empty list is sorted and it does return true. And it's often the case that a singleton list can also cause a problem, but that's okay in this case. So that seems to have fixed the problem for this particular function. Okay, that's the end of that.